Hello everyone and welcome to my talk. We're going to cover observability for APIs. We're going to see what observability is and what it means for APIs and how it can help us in the areas of API security, governance, and operations. So observability is something that I've been coming back to often in recent projects. So we're building an API or a distributed system, and suddenly we want to understand how users are engaging with the API, what the typical user flow is, what it looks like, how many unauthorized requests per second do we have, how many requests per second do we have, how many errors do we have, what is the biggest source of error, or what are the common latencies in the API. Now, with traditional access logs, the typical request logs that any web server produces, it is quite difficult usually to answer most of these questions. We don't have enough information to understand how the system is working inside, and so we need something more sophisticated, and that's where observability comes in. And so the goal of this talk is not to tell you how observability is going to help you solve all of your problems. It is to get you thinking about observability and how it can help you improve your operations in your projects, whether that is at work or with your personal projects, and generally see how we can make our life as API practitioners easier. Before jumping into the details, let me introduce myself. My name is Jose. I'm a consultant, author, and instructor. I work with organizations of all kinds and shapes, from small companies to big corporations like AIG and IKEA, and I help them to build complex distributed systems with all the integrations in between. I'm the author of Microservice APIs, the book over here, which I wrote as a guide to help readers embrace and start building APIs and microservices following best practices and principles. And if you're interested in grabbing a copy of the book, feel free to use the URL on the screen together with the discount code that is shown below the URL. You will get a 45% discount on the purchase. It is valid for a few months. And I am also the creator of Fencer, which is an automated API security testing tool. It is available on GitHub. It is written in Python, so you can install it with pip. And it is very much in the beginnings of the project, so don't expect much from it yet. But if you're interested in this kind of tooling, feel free to check it out, give me your feedback, or contribute to it. I really appreciate those efforts. I'm also collaborating with a startup called Relio. The idea here is to build what we might call a distributed compiler for APIs. So it is a tool that looks at the code, at the implementation, and it compares that with the API specification, and it tells you whether they are different and how to solve those differences. If you're interested in microservices and APIs and that kind of content, and in particular the content I produce on these topics, I encourage you to connect with me on Twitter or LinkedIn, or to subscribe to my newsletter on Substack for Maker APIs. It is completely free, and I occasionally drop some of this content on there. Now, the agenda for now in this talk is to see what observability is, what it means for APIs, how can we make the most of it, and we're going to see how it helps us specifically in the areas of security, governance, and operations. Now, as I talk about some of these topics, I'm going to push the boundaries of some of these definitions. So I may talk about governance or security, or maybe observability as well, in ways that deviate a little bit from the standard definitions. But the goal here is not to cause controversy on those topics. It is really to get us thinking about observability and how we can make the most of it in APIs. So the first question is, what is observability? And the way I would like to address this question is to begin by showing you some of the questions we might be able to answer if we have proper observability in place. So some of those questions are, what does the typical user journey through the API look like? How many unauthorized requests per second do we have in our API? What is the biggest source of errors? What flows characterize non-bias? In other words, if our API or platform is selling products or services or subscriptions, and we have two groups of users, one of them comes to the platform, uses the API, and end up buying what we are offering through the API. The second group of users don't buy what we are offering. Is there any difference in the user journey of the two groups? Can we detect that? Can we analyze it? Can we do something to optimize it? Can we detect abuse of our APIs? Are customers using the API as intended? So we usually design our APIs with at least one or a few possible user journeys in mind. Are our customers following that user journey, or are they deviating from that user journey? Is that deviation something we have to look for? Is it malicious? Is it just the fruit of a misunderstanding of our documentation? What's going on there? So in my experience, most organizations can't answer most of those questions, and that is very bad news for those organizations. It is very good news for their competitors and their hackers, but it is very bad news for the organizations that don't have observability. The reason they can't answer those questions is because they don't have the necessary data and the necessary monitoring. That means they don't have the necessary observability. And if you don't have observability, most likely you're getting hacked without knowing it, you're losing customers without knowing it, and you're missing out on crucial feedback about the quality of your APIs. And these are all really bad things if we are working with APIs. Just to give you one anecdote here. I recently spoke with an organization based in the US. They offer most of their products and services through APIs, and they've been around for a while. They have a good base of customers. But they've got to a point in which it is very difficult to continue evolving the API, to continue making changes to the code base, and keep those changes in synchronization with the API documentation. This is becoming extremely frustrating for the customers because they can't simply adopt the new changes. Something changes, but the documentation is incorrect. They can't embrace the new changes. But also, breaking changes are introduced in the existing functionality that is not correctly documented, and the integrations are breaking. And so they are losing customers because of this frustration. Now, there are many things wrong in this workflow. There are things we can address in terms of workflow, tooling, and practices to make sure that these things don't happen again. But the point is that this organization is only getting to know about the problem when the customer tells them. So our customer has gone through the pain of trying to figure out the documentation, trying out different things with the API, and finally raising a support ticket. That's the final step. That's too late. By the time a customer has done that, a few others have already dropped from the customer base. And so this is a situation we really want to prevent if we offer products and services through our APIs. And the thing is, we can operate. APIs are things we create ourselves, we control them, we operate them. There is no reason not to know every single detail about what's going on with the API. And observability is what is going to help us here. Observability won't solve those problems, problems in API documentation, user errors, latencies and such, but it's going to highlight those problems. It's going to give us the visibility. And so back to the original question, what is observability? The standard definition is the ability to measure and describe the internal states of a system based on its outputs. Now, outputs are things like traces, logs, and metrics, and this is what we call the 3 pillars of observability. If you're interested in the tooling in this space, in the open source tooling, that something to look at is OpenTelemetry. The Cloud Native Foundation is sponsoring this development, and they are leading efforts in making a standard in this space. The philosophy behind OpenTelemetry is to make it easy to implement observability in our systems. So they have this idea of instrumentation. The idea is to create tooling that is easy to inject in our system and get the benefits of observability. So it might be something like installing a library and configuring the plugin, and already we have observability in place. So if you're interested in the tooling, check that out. What we're going to do here is we're going to look at the fundamentals of observability and how to use it to improve our API operations. And so to define metrics, logs, and traces, logs are records of a specific event. We are all familiar with them. It's the traditional logs that we have in any web server. Looks like this. So information about the URL that was requested, the HTTP method, the status code of the request, so on and so forth. Metrics are measures that capture system behavior, things like availability and performance. So they measure things like CPU utilization, memory utilization, maybe number of requests per second, maybe number of unauthorized requests per second, perhaps average latencies. Now, traces. So what happens in distributed systems often is that a request comes to our system. So like you see here, the order service, and to process that request, we may have to perform some transactions with the database, but we may also have to send some requests to the services, like the user service and the payment service here. The problem is, once the request leaves the order service, we lose track of it. So whatever happens in the user service, we don't have visibility of it from the order service perspective. And if an error happens in the user service, it is very difficult. Just by looking at the request logs of the auto service and the user service, it is very difficult to connect the two events and see what happened. And so that's where traces come in. So traces will, if you use, for example, OpenTelemetry, it will inject a trace ID in every request that comes to the system, and that trace ID will carry forward to any other request that comes from the original request. And so if an error happens in the user service, we can look at the wider context of the request by looking at the trace IDs. We can look for the trace ID in the user service and see what is the original request that caused the error. Now that is observability. So how is this good for APIs? The first thing I would like to say is that good observability serves different stakeholders. So whether we are from a cybersecurity team, or from governance, or from product management, or from development, we should be able to look at the output of our system and draw relevant information for ourselves. So cybersecurity may want to draw a picture of our security posture in APIs. Governance may want to answer questions about essential KPIs of API usage, and development may want to be able to trace errors through the system. So we should be able to do all of those things with the same output. That takes us to the next point. We should be able to reproduce and trace user flows with the API. And that would allow us to reproduce errors. So for example, sometimes an error happens in a sequence of steps. We need to perform a series of steps to accomplish a goal. An example here is from an API I've recently built for our clients. It's the process of decommissioning an item. To accomplish that goal, you have to follow a series of steps in a specific sequence. The problem is, if you make a mistake in one of those steps, that's going to carry forward and it's going to cause an error at the end. And to be able to analyze the problem and see what actually caused the error, we have to be able to reconstruct the whole user flow and reproduce the steps one by one. That's going to allow us to see which step introduced the error. So we should be able to do that with APIs. That is going to give us insight about user behavior, whether there's something that is not understood about the API documentation, whether there is something that we didn't design very well in terms of user flows. It's going to be very important feedback to improve our APIs. The next step, the next point is something I took from Matthew Skelton. And so he makes the point, and it is true, that often when an error happens on the user service, we usually think, well, if that's the user service domain, it's something the user service team will have to figure out and resolve by themselves. But perhaps what happened here is that the error in the user service was caused by something that happened in the original request. So maybe the client set a parameter in the request that was carried forward by the auto service, sent to the user service, and that caused the error eventually. And so to actually properly debug this problem, we have to put that request, that error, into the broader context, the actual context of the request, and bring the relevant stakeholders on the table to analyze the problem and decide how we can prevent it from happening in the future. And so that's where distributed tracing comes in as well. The final point I think is very important. Observability, good observability, is tailored to the specific needs of our business. In other words, observability speaks the language of the business. So when we see an error in the logs, it's not a random post-request error. It is a specific error in a specific business context. To give you an example of that, this is a typical request error that we might find in any web server. We know it's a put request on a specific resource, specific operation, it caused a specific error, and we have the stack trace. Now that's okay, but it's not good enough. A better implementation would be we have trace IDs. So that would allow us to put the error into the bigger context of that request. So maybe this is caused by something that happened in another request earlier in the cycle. That's good enough, but really the best situation is if we can put the specific business context of the error. So this is not just a random put request error. This is something that happened in the context of submitting a statement of work through the website. And this is really important for APIs that are going to be used externally. So if we are selling this API, the users are going to be interacting with it typically through some sort of interface that exposes the business operations that we implement through the API. And so when they encounter an error, they're not going to come to us and tell us that they had some sort of put request error or something similar, they're going to tell us that they tried to submit a statement of work and it didn't work. They tried to sign a contract and it didn't work. They tried to decommission an item and it didn't work. And so ideally, we should be able to look into our logs and look for these business events and find the errors in the context. This is also going to help us as developers and API practitioners. Is going to help us look at these errors and communicate them to the business more effectively, because they speak the language of the business. Now, that is how API observability is good for APIs, but how is it specifically helpful in security governance and operations? Starting with security, the first thing I want to say is that according to research by IBM, it takes on average nearly 300 days for organizations to identify and contain a data breach. That's not really very good. We can do better than that with the help of observability for sure. But the thing is, a lot of those data breaches traditionally happen through strategies like phishing attacks and things like that. But increasingly, they're happening through APIs. And moving forward, we're going to see more and more data breaches happening through APIs. And back to what I said before, APIs are things we build, we operate, we have full control of. So there is no reason for us not to be prepared to see everything that is going on with the API and detect any malicious activity and flag it as soon as it happens. So we should be able to bring that count down to at most 1 day or 1 week at most to identify and contain a breach in our APIs. The OWASP list of vulnerabilities for APIs in 2019 included insufficient logging and monitoring as a core vulnerability in APIs. In 2023, this vulnerability is still present, but is mentioned across all the vulnerabilities. We're going to mention an example of that in a second. Final thing I want to say here is lack of observability means we're not ready to tackle security issues in our APIs. We don't have the necessary level of readiness to address and manage our API security posture. So that's the first thing we have to address. This is an example of what happens when you launch a service online. So this is a screenshot I took when I deployed a load balancer on AWS for a client. This is moments after the deployment, even before we started to interact with the API ourselves. And so what you see here is an automated profiling of the API. These are automated tools. They are looking for available services online, and they are going to be profiling the service, looking for open holes in our system that a hacker can exploit. So this is going to happen automatically. And what we need to do is we have to be prepared to face these threats. We have to be protected, and we have to be ready to see what's going on, detect malicious activity, and address it. Another thing I want to say, the security landscape is continuously evolving. Hackers are continuously finding new and creative ways to exploit our systems. Even if our systems are completely secure at a single point, those systems will continue evolving in the future. We will add additional functionality, additional endpoints, additional parameters. Those new elements can open new holes in our system. So we have to be continuously assessing and observing our security vulnerabilities. And so one risk I want to mention here is this vulnerability that was introduced in the WASP list of API vulnerabilities in 2023, unrestricted access to sensitive business flows. It means the ability of a user to abuse our business model through the API because of flaws in the design. So if you tried, for example, recently, you tried to buy a PS5 online through an online retailer, you may have had the frustrating experience that the console is never available, is never in stock. The reason is because malicious users use automated tools to buy the whole stock and resell it at a higher price. This is known as scalping. It's a typical threat in APIs in the e-commerce space. The UK Driving Authority had the same problem recently. So to obtain a driving license, you have to pass an exam. To pass the exam, you have to book a slot for the exam online. And what was happening was malicious users using these scalping bots were buying out all the slots available and reselling them at a much higher price, sometimes double or even higher price than the original one. The Driving Authority has put measures in place to prevent this from happening in the future, but I think what is important to note here is malicious users will always find creative ways around our measures, so we should be looking for what's happening with our APIs, detecting malicious activity and reacting to it. So just to summarize what's the benefit of observability for API security is we should be monitoring user behavior all the time, looking for unusual behavior, unexpected flows, unexpected ways of using the API. We should track unauthorized requests, where they are coming from, what's the user profile, and we should be watching very closely data transfers from sensitive data endpoints. So if we have an endpoint that exposes sensitive data about a user or some conditions of the user, or payment, financial information, because we own the API, we know it, we should have an idea of what is the typical data transfer from that endpoint, what it looks like, and as soon as we detect unusual data transfer from that endpoint, we should flag it, we should look into that. It doesn't have to be something malicious, but it may be, and so we have to be able to detect those unusual activities and look into them. Now, moving on to governance, we want to be able to address a different kind of set of questions here. So we want to be able to trace user flows, analyze user experience. We want to be able to answer the question of whether the API is being used as intended, whether the design is good enough, the user experience is good, whether there is something we have to do here to optimize user experience, whether our customers are abandoning the API at some point in the journey, and whether that's something we can optimize, whether the API is meeting the expected KPIs. So we build those APIs to give value to the business. Is that value being materialized or not? Very important also, whether the API is correctly documented. So our job in governance, one of the jobs in governance, is to ensure that the APIs are correctly documented, that they deliver business value, good user experience. In terms of documentation, often, the example I mentioned before, we are not able to provide good documentation for the API changes that we are making. So we should be able to detect that in the documentation and spot those problems before the customer tells us. In terms of analyzing user flows through the API, something I would recommend here. If you watched Frank Kilcomin's talk in this conference, he presented the workflow specifications. So this is something that allows you to document the expected user flows through the API, the sequences of steps that are expected. And so this is something you could use and leverage to look for unusual activity, unusual ways of engaging with the API. And now again, this doesn't mean that those unusual engagements are malicious. They may just be the product of a lack of understanding of how the API is supposed to be used, and that is important feedback about our the quality of our API design, but it is also something that we could leverage for security. And then moving on to operations, now we want to address a whole different set of questions. First of them is whether we have shadow APIs and zombie APIs. So shadow APIs are endpoints and APIs or API versions that shouldn't be there. They are undocumented, they are not supposed to be part of the API. Maybe we included them for testing purposes or in a first round of iterations on the API design, but they were not supposed to be there as part of the API design. However, sometimes those implementations get leaked, and if a malicious user discovers them, they may get access to sensitive operations or sensitive data about our system or from our system. And so if we have good observability in place, we should be able to detect that. Zombie APIs are APIs that should be deprecated, but they are still there. We forgot to actually retire them. And so as part of operations, one of our jobs is to manage the release and deprecation of APIs, make sure the rollout is smooth, and that we eventually retire APIs that shouldn't be available anymore. However, sometimes we forget to deprecate those old versions, or maybe they get redeployed at some point by mistake, and so that's something we should be able to watch for in our observability system. We should be able to trace problems through our systems, even if those are in distributed transactions. So we should be able to put them together and look at the bigger context of a problem. We should be able to diagnose problems as soon as they occur, not when the customer tells us, but before they tell us, exactly as soon as they happen in our system, so that we can, if possible, provide the fix even before the customer tells us. And we should be able to reproduce user flows to understand how users are engaging with the API, and to trace and reproduce errors. And finally, we should be able to understand the topology of our system and the dependencies between services. So we might find that there are any two services that are often talking to each other more than any other two components in the system. There's an opportunity here maybe to optimize the network configuration so that it is optimized for communication between those two services, or maybe it prompts us to redesign our system, and perhaps we decide that those two services are so much talking to each other that maybe it makes sense to put them together and ship them as a single system, single service. So these are some of the questions that we might be able to address from an operations perspective. And so finally, some takeaways. Here, API observability is hard, but it is necessary. It is a precondition to assess and address our API security posture. Good observability is tailored to our business needs. It speaks the language of the business. And so when we find an error in our traces and logs, it is not a random put request error. It is an error in a specific business context, when a user is submitting a statement of work, signing a contract, or something similar. And we can communicate with our stakeholders and align with them on those errors and communicate accordingly. It serves different stakeholders. So whether we are from cybersecurity, from API governance, from product management, from QA, or from development, we should be able to come to these outputs of our system and draw relevant information for our team. And finally, it should help us, good observability should help us not only answer questions about the system, but it should also give us actionable feedback, actionable insight as to how to improve the system. So from a security perspective, we want to have actionable insight on what we have to do to protect our system, to block certain users, block certain flows. But from a governance perspective, we want to have also insights about how we can improve our API design, or how we can make the API more useful to our users. So that is everything I wanted to say. I hope that was useful and you got some interesting ideas from here. I'm going to be doing a lot of work on API security, operations, and observability in the coming year, in 2024 and following years. So if you're interested in this, please connect with me. I'm happy to talk about this topic anytime with you on Twitter or LinkedIn. And again, I will be dropping content on these topics on my newsletter in Substack. And finally, if you're interested in my book, feel free to go back to the first slides in the presentation to grab the URL and the discount code to get a 45% discount on the purchase. That's everything I wanted to say. Any comments or questions, I would be very happy to address anytime through any channel. And thank you for attending, and see you soon.